Now solve question 5. Question 5. That is question 5. We're going to balance this equation also. Let's bring out the equation properly so that we can balance it now. This is the equation. Now let's count the number of atoms present. First of all, for this tin, this SN tin, there is only one atom, so I put 1. Hydrogen, we also have 1 atom. For nitrogen, we also have 1 atom. For oxygen, we have O3, that's 3 atoms of oxygen. For SN tin again, we have 1. For oxygen, we have 2 atoms of oxygen, O2. Nitrogen, we have 1 here, and for oxygen O2 we still have 2 atoms of oxygen. For hydrogen here we have 2 atoms, H2, and then here we have 1 atom of oxygen. Okay, let's put letters to represent the coefficient of the balanced equation. A, B, C, D, E. Good. So let's now find the actual number of atoms by multiplying all these numbers by their respective coefficients. 1 multiplying A, that's A. 1 times B, that's B. 1 times B, B. 3 times B, 3B. 1 times C, C. 2 times C, 2C. 1 times D, D. 2 times D, 2D. 2 times E, 2E. 1 times E, E. Fine. These are the actual number of atoms of various elements present in the chemical equation. So we go ahead to balance. We pick those elements one after the other. I'm starting with tin, SN. So let's start with that. SN. How many atoms of tin are present here? That's it, A. Any other tin on the reactant side? None. So I write A is equal to, let's go to the product side to look for tin. How many atoms of tin are present? That's C. That's C. No other tin atom in the product side, so I'm done with tin. Let's go to another atom. Let's go to hydrogen now. Hydrogen. How many atoms of hydrogen are here? That's B. That's equal to, what about air? We have 2E atoms of hydrogen. 2E. I'm done with hydrogen also. Let's now move on to nitrogen. Nitrogen, on the reactant side we have B atoms of nitrogen. Then on the product side, this nitrogen, that's going to be D atoms of nitrogen. Then for oxygen, we have 3B atoms of oxygen on that side. Then on the product side, this is 2C, oxygen here is 2D, oxygen here is E. So we're going to add all the atoms of oxygen there. It will be 2C, which is this, plus 2D plus E. Good. So we've gotten all our equations here. Which one is the letter with the highest coefficient? I think that's B, having coefficient 3. So let's start by making that B equal to 1. Let B be equal to 1. Let B be equal to 1. That's how to start. The value might change later, but at least we start this way. If B is 1, let's come to this equation here, this second equation, that's H for hydrogen. If B is 1, B is equal to 2E, eventually becomes 1 is equal to 2E. What then is your E? That means your E is half. Okay, B is 1, you keep that somewhere. E is half, you keep that somewhere. B is 1, B is 1, E is half. Let's come to this last equation here. For nitrogen, B is equal to D, and of course we've gotten B. We said B is 1, so D also is going to be 1. Okay, we've gotten D also. Let's now move on to the last equation, which says 3B, that is 3 into B, and B is 1, so I write 3 into 1. 3B becomes 3 into 1 is equal to 2C. I don't know C yet, so I put 2C there, plus 2D. I've gotten D to be 1 also, so that is 2 into 1 plus E, and E has been gotten to be what? To be half. Okay, this 3 is equal to 2C plus 2 plus half. So 3 is equal to 2c plus 2.5. How then do we get our c? 2c is going to be 3 minus 2.5. Okay, let me finish up here. I'm saying that 2c is equal to 3 minus 2.5. 3 minus 2.5 is half. So the 2 comes down. Our c is going to be 1 over the 2 will come and meet these 2. That's 2 times 2 under, making 4. So we've gotten c also. And from the very first equation, a is equal to c. If a is equal to c, that of course means a is also 1 over 4. So all these values we've gotten, let's bring them together now. Let's bring them together. We got a to be what? We said a is what? A is 1 over 4. What about b? B is 1. What about c? C is 1 over 4 also. What about d? D is 1. What about is there e? Oh, we didn't get e at all, did we? Okay, we got e. E is half. E is half. So e is equal to half. Now what's the LCM of the denominators here? 4, 2. LCM is 4. So let's multiply all the values by 4 to turn them to whole numbers. To whole numbers. So a is going to be 4 times that 1 over 4. B is going to be 4 times 1. C is going to be 4 times 1 over 4. D is going to be 4 times 1. E is going to be 4 times half. Good. What will this be now? A will be 4, we cancel 4, so A is 1. B will be 4 times 1, which is 4. C will be 4 cancels 4, C is 1. What about D? 4 times 1, that's 4. What about E? E is 4, 2 goes in 4, that's 2. E is 2. So let me put the values. You know, A is 14, yeah? So, and A is 1. So 1, you don't have to write the 1. 1 for the zinc. For the tin, then B is air, which is air. What's our B? 4. So we're going to put 4 there. Then tin, for this place we have C. C, that's 1. You don't have to write 1. Just leave it like that. Then D is 4. So we're going to put 4 here. Then for E, E is 2. So we'll put 2 here. I want us to now check whether the equation is balanced or not. Whether the equation is balanced or not. Alright. We have what here? 1, 4 here, 1, 4 here, and then 2 here. Let's check for tin. 1 atom of tin on the reactant side, 1 atom of tin on the product side. Balanced for tin. Hydrogen. 4 atoms of hydrogen on the reactant side, 2 times 2. 4 atoms of hydrogen on the product side. Balanced for hydrogen also. What about nitrogen? This 1 times 4. 4 atoms of nitrogen air. 4 atoms of nitrogen air. Balanced for nitrogen. What about oxygen? This is 12. 3 times 4, that's 12. We have 2 oxygen on the product side here. This is 8. 8 plus 2 making 10. Then another 2 oxygen making 12. 12 atoms of oxygen on the reactant side. 12 atoms of oxygen on the product side. So it's also balanced for oxygen. So this is a perfectly balanced equation, chemical equation. It's a perfectly balanced chemical equation. So you can see that the method is simple, the method is easy.